Let's look at the effect of doing subnetting. Okay, in the earlier example, we have a /24 subnet and a /25 subnet. Okay, so when we increase the subnet bits from /24 to /25, we have increased the network bit by 1. This means that we have created from one network to become two networks. Okay, and at the same time, by increasing the one network bit, we have also decreased one host bit. This means that the total number of hosts inside the network have reduced by half. Okay, we can look at it in this example. Okay, the same example 10.1.2.0/24. Okay, so with that, we have actually 254 host address. This is the broadcast address. Okay, so this /24 means that there are 24 network bit and 8 host bit. Okay, when we increase the network bit to be /25, okay, we have effectively cut this network into half. The first half will be from .0 to .127. This is a network address, this is a broadcast address. Okay, the second half will be from .128 to .255. Okay, so in this example, we have 25 network bits and 7 host bits. By increasing the network bit from 24 to 25, we have created two networks from one network. So we have doubled the number of networks, but the number of hosts have reduced by half. Okay, if you don't understand why we have created two networks, okay, let's further explain this. Okay, I'm going to put this here. Okay, 10.1.2.0/24. Okay, this means that my networks is 10.1.2. My host bit, okay, I'm going to make my host bit in terms of binary. It will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this first 8 is my host bit. Okay, so this is /24. Okay, so this will be my network. Okay, and then my broadcast will be 10.1.2. All ones, which is .255. This will be my broadcast. Okay, so my valid host will be from 10.1.2.1, all the way down to 10.1.2.254. So these are my valid host IP address, the range of the valid IP address that I can use. Okay, what happens if I change this to /25? When you change it to /25, this means that this bit, okay, instead of being a host bit, it has become a network bit. So I'm going to move this to the network side. Okay. Okay. Okay, now this was initially a host bit, so you can change this. But when we change this to a network bit, okay, this have helped us to create two networks, the network 0 and the network 1. Okay, so when we set this to become 0, this will be my first network. Sometimes we call it the subnet 0, and this will be my second network. Okay, so this will be the host bit. So what is the broadcast address of the first network or subnet 0? Okay, so it will be 10.1.2.0. Okay, this will be the broadcast address of my first network. Okay, so I may convert this number, okay, into decimal. This will be 127. Okay, so I'm going to just put it here, 127. Okay, this is 0. This is 1. Okay, so this will be my first network. My second network, 10.1.2.1. Okay, remember this was initially a host bit. Now I make it a network bit, so I change this to 1. This will become my second network. Okay, so this will be my network address, okay, which is 128, the network address of my second network. Okay, and this will be the broadcast address of my second network, which is 255. Okay, 254 will be the last IP address that I can use. So this is my broadcast. Okay, so as you can see, effectively we have created two networks. The first one is over here, okay, where the bit that we borrow, okay, this bit initially was a host bit, now become network bit. Okay, we set it to 0, this will become my first network. My second network will be here, where this bit 25, we change it to 1. Okay, so we basically have created two networks, here and here. But the size of the network have been changed. Okay, here used to be 256 IP address over here. We have now divide it by 2. So this one will have 128, this one have 128. Okay, so by borrowing 1 bit, okay, we have created two networks. How about if we borrow 2 bits instead of 1 bit, to /26? Okay, then how many networks have we created? Okay, I'm going to delete all this. When we borrow 2 bits, these have become the network bits. Okay, 2 bits have become the network bits. Okay, so how many different networks we can use? We can use the .00. Okay. We can use 01, the second network. Third network will be 10. And finally, the fourth network will be 11. Okay, so by borrowing 2 bits from /24 to /26, we have created 4 different networks, and the size of the network have been divided by 4. Okay, so this is initially 256, this 128, and here will become 64. Okay, 64. Okay, so by borrowing from /24 to /26, we have created 4 networks, and each network will have 64 IP address. 0 to 63, 64 to 127, 128 to 191, 192 to 255. How about if we borrow 3 bits? Okay, so obviously if we borrow 3 bits, okay, we have in fact created 8 networks. This is the first network, second network, third network, fourth network, fifth network, sixth network, seventh network, 8 network. We have created 8 networks. Each network becomes smaller. So again, this is 256, 128, 64, and here each network will be 32. Okay, so if you count, this is from 0 to 31. 0 is the network address, 31 is the broadcast address for the first network, 32 to 63, 64 to 195, 96 to 127. Okay, so actually you can see there's a pattern. Okay, so because we borrow 3 bits, so the number of host bits will be left with 5. So with 5 host bits, how many possible host IP or how many possible IP address can you use? So it's 2 to the power of I, 5 is 32. So obviously you need to minus 2 for the network and the broadcast. Okay, let's say we don't minus 2 first, so we just leave it as 32. Okay, so with that, okay, you can easily calculate the network address of the 8 networks by adding 32s. Because if you remember, the size of each network have now been reduced to 32. Okay, so the first network address will be .0, second one will be .32, third one will be .64, 32 plus 32 give you 64, followed by 96, followed by 128, 160, 192, and 224. So if you understand the concept of subnetting well, actually it's quite easy to do subnetting. You don't even need to do the binary conversion. So for example, /24 to /25 means that your number of hosts in one network is actually 128. Okay, 128 because you have only 7 host bit here. Okay, this is a /25, you only left with 7 host bit. Okay, 2 to the power of 7 give you 128. So the first address is .0, the second address is .128, 0 plus 128. If you borrow 2 bits from /24 to /26, so /26 means that the number of host bit has been reduced to 6. 2 to the power of 6 gives you 64, which means that each network has 64 IP address. Okay, so to find out the network address of each network, you just add 64. 0 plus 64 give you 64. 64 plus 64 give you 128. 128 plus 64 give you 192. So you can get the network address of each of the network okay, quite immediately. Okay, so this is actually an easier way to do subnetting rather than going back using the binary method. Okay, so let's look at the network prefix. Okay, a /24 means that how many IP address you can use. /24 means that you have 8 network bits, so 2 power give you 256 IP address, but you need to minus the network address and the broadcast address. So this gives you a possible of 254 IP address that you can use. /25 will be 2 to the power 7 minus 226, and so on. Okay, and this will be the respective subnet mask for the prefix. So using this table, you can use it for your subnetting questions. Okay, now let's do one example. Okay, these are exactly the same example as in your network fundamental, where we have this topology. There are 4 subnets. Each subnet have the different number of hosts, IP address that you need to support, and this is a block of IP address that you are given /21. Let's design the variable length subnet mask to do subnetting for these 4 subnets. Okay, the first step, which is a very important step, is to first sort the subnet according to the number of host address required. Going back to the earlier slide, okay, we have 4 subnet, 100 hosts. This is the biggest subnet, followed by subnet 4, followed by subnet 3, followed by subnet 2. Okay, so I sort them up 1, 4, 3, 2. This is the number of hosts is required. Okay, so to support 100 hosts, how many host bit do we require? So we need at least 7 host bit. 2 to the power 7 minus 2 give you 126. 6 host bit will be 2 fill. Okay, 2 to the power of 6 will only give you 64. Minus 2 will 62. So it cannot support 100 IP address. So 2 to the power, so 7, you need at least 7 host bit. Okay, so for subnet 4, we need at least 5 host bit, okay, which give us 30 IP address. Subnet 3, 4 host bit, and subnet 2 will be 2 host bit. Okay, 2 host bit give you 4 IP address. You need to minus 2 for your network address and the broadcast address. This gives you 2, which is exactly what you need. Okay, now based on that, okay, we can count the number of IP address, including the network and broadcast in each network. So the first network, 7 host bit give you 128 possible IP address, again including network and broadcast. To the power of 5 host bit give you 32, 4 host bit give you 16, 2 host bit give you 4. Using this number, we can do our subnetting very easily. Don't need to use the binary method. Okay, this is a solution. Actually, you can derive this solution very quickly. Okay, how? Okay, if you look at the earlier slide, subnet 1, you need 7 host bit, will give you a total of 128 IP addresses, including network and broadcast address, remember? Okay, so what you need to do is, this is the first address that you are given. Okay, it's a /25. Okay, so why /25? Because we have 7 host bit. We need 7 host bit. So 7 host bit means 25 network bit. Okay, with /25, how many IP address does this have? This is at 128. So to come to the next, the network address of the next subnet, we just need to add 128. So this is the network address of the next one. So this is a /27 because the subnet 4, it need 5 host bit. So 5 host bit means that the prefix will be /27, and 5 host bit give you a possible 32 IP address. So we just add 32 to it. Then this will give me the network address of subnet 3. So if you remember, subnet 3 is 4 host bit, give you 16 IP address. So 4 host bit is /28, 16 IP address, plus 16, this gives me the network address of the last subnet, okay, which is a /30, which means 2 host bit. So this method that you quite easily find out the network ID of all your 4 subnet without even going through the binary.